Okay, so hello everyone, welcome back again. In this video, we are going to talk about the solution of linear equations, or I would say the solution of system of linear equations. So suppose I have equation 1 that is here, that is a11 x1, a21 a12 x2, a13 x3 going up to a1n xn is equal to b1. The second equation is this, and then another equation is this. So there are n equations and I have n variables. Those are x1, x2, x3 up to xn, and I want to find out the value of x1, x2, x3 up to xn. So this system of linear equations give me this matrix system, that is matrix A, which contains coefficient of this system of equations, and then vector x, which is unknown, which we will try to find out, and then there is this vector v, which is having the right hand side of these equations, the coefficients. So I have this system, that is ax is equal to v, and I want to find out this. The solution of this ax is equal to v means I want to find out the vector x, and in this part of this course we will try to understand how to find out this vector. So there are 3 points about this system, that is ax is equal to b. So suppose matrix A is m cross n, which means it has m rows and n columns. So the first point is that if m is greater than n, which means the number of rows is greater than the number of column, then we may not find the solution, because the number of rows the number of rows are uh, greater than the number of columns. So it might be that the all the values of x vector cannot satisfy all the equations. The second point is that if m is less than n, then we may have more than one solution. So this system will not have a unique solution. The third point, or the third case which comes out of it, is m is equal to n, and in this case we will have a unique solution if mod of a is not equal to 0. So in this part we will see that the number of variables and the number of equations are same, and the mod of a is not 0. So in this part we will try to understand this case where m is equal to n. So there are so this matrix system is given as ax is equal to b. So there are two types of methods. So we have two kinds of methods. First is known as direct methods, and in this direct methods we have Gauss elimination method. Second method is Gauss Jordan method. This is A. And the third method is LU decomposition method. And the fourth method which comes in this category is Thomas algorithm / method. There are different variant of this Thomas algorithm or Thomas method, like line by line Thomas algorithm method, which is out of the scope of this course. We'll try to learn that in the CFD. The second type of method is called indirect methods. or iterative methods. And in this we have Gauss Seidel method, and the second method is Gauss Jacobi method, and the third method is successive over relaxation method. So we'll try to understand each of these methods in detail in the next video. So the first method which we will learn is Gauss elimination method. So let me give you one more thing, that is, in these direct methods we will basically directly try to find out the inverse of matrix A. So essentially, if we have the inverse of matrix A, then we can solve this. X is nothing but A inverse B. So essentially we are trying to find out the inverse of matrix A, and then we'll multiply it with V. And so in this case we will not have any iterations, but in the indirect methods case we will have the iterations to solve the system Ax is equal to B. So what we will do, we'll try to guess the value of X, then put it into this system and then recalculate it by using some iterations. So that we'll understand in Gauss Seidel or Gauss Jacobi method. So in the next video we will straight away get into the Gauss elimination method. Thank you.